Dilshan Perera and I am undergraduate of Faculty of Information Technology, University of Maldives, Sri Lanka. My research is about computer-aided diagnosis systems for detection of lung cancer nodule. I am the first author of this research and my co-author is Dilshan. And this is part of my final year project. This is the overview of my presentation. Let me start with a brief introduction. An affliction of exceptional cells growing and multiplying into a tumor is called a lung cancer. Cancer cells may be born over lymph fluid that inundates lung tissue or from the lungs in blood. In this work describes the best imaging techniques such as computer tomography images are predictable for lung cancer disease. Some systems do not have level of efficiency and some systems still has to be developed to achieve highest efficiency 10 to 100%. Machine learning and image processing techniques has been achieved to classify the lung cancer. Here you can see the proposed model for this work. This model starts with image pre-processing, then move on to image segmentation, then pitch extraction, then lung cancer cell identification through data mining, then represent the diagnosis result as a probability measurement. Let's start from the image pre-processing. Image pre-processing commonly affected by extracting low-frequency background noise, enhancing or removing data images proceeding to computational processing and normalizing the intensity and concentration of the individual fragment images. So, image pre-processing stage are mainly categorized in three stages. First one is computer tomography lung disease image taken as its input image. So then we extracting window and grayscale image by resizing the computer tomography image by 16 into 16 pixels. So then we can apply median filter image processing techniques are allowed to reduce the image noise from the images. So this is the basic step of the proposed model and other stages are dependent on this stage. Okay. Then image segmentation. It is assigned to convert of separating an image into recognizable distinct regions by grouping and organizing together neighborhood pixels placed and any determined comparison criteria. Here you can see these three pictures. First one is the CT scan image before segmentation, the lung image. So second and third images are respectively left and right segmentation images. The most important thing is the CT scan can identify the cloudy surfaces on that image. So then we move on to the most important part of the model, feature extraction stage. This feature extraction stage is an imperative stage that allows to usage of techniques and algorithms for isolating and detecting different shapes or required portions of the disposed image. Feature extraction reduced representation set of characteristics can be transformed by input data. So therefore, input data is converted into the set of attributes done by extracting image features. In this figure, here you can see figure 3, 4, 5, 6, 7 and 8, original grayscale image, median filtered image, Gaussian filtered image, binarized image, watershed segmented image and cancer mark image respectively. So in figure 6, there are two dots, two white dots on black background. So it was marked by a cancer image through CT scanner. So nodules. So you can see this. So now you can see this classification result as sample of a researcher. So the diameter of the tumor 1 is less than 3 centimeters, and we can identify that is the primary stage of the disease. The diameter of the tumor 2 and tumor 3 are between 3 centimeters and 7 centimeters, and the cancer nodules are spread some areas in the lung. Tumor 4 is any size larger than 7 centimeters, and it is the most critical stage among all stages. So, however, there are certain number of current issues in computer-aided diagnosis systems for detecting of lung cancer nodules. It is difficult to image processing, which reduces the process complications as well as isolates various desired shapes of a given image, rescaling and selection of region of the image. Not only digital image processing cannot be isolated from the other methods, image diagnosis using reasonably in order to make up the in order to make up for the shortcomings of the other methods. In conclusion, the digital image processing techniques using image segmentation, image compression, and edge detection provides better accuracy and compression ratio of an image. This study described the features extracted from the segmented image acts as the foundation of the next stage. Therefore, this study described the various image processing techniques and automated intelligence systems for lung cancer detection and classification. Most importantly, let's now talk about future directions of computer-aided diagnosis system for detection of lung cancer nodules. This method consists of applying image processing techniques to detect abnormalities in CT scan and training the model to identify the cancer nodules through CT images by labeling dataset of lung CT scan images. With the system to reduce time taken for the identification process by detect lung areas from the computer tomography images and implement a system for detecting the presence of the lung cancer with the using of CT scan images by using machine learning and image processing. So, I would like to offer my gratitude to my parents, my friends, and my co-author Kulavansa, senior lecturer at the Department of Computation Mathematics, Faculty of Information